Here's a function called isPal. It decides whether a list reads the same forwards and backwards. Hand it the list AB and it answers true. That is wrong. The temptation now is to start changing lines until the answer flips. Resist it. There is a disciplined way to find a bug, and it looks a lot like science. Debugging is a creative process, and there is no recipe for it. But there is a good way to approach it. Treat it as science. Do not randomly change things and hope it works out. Instead, gather the test cases that failed and look at them together. Often they have something in common, and that shared feature points at one small piece of your program, the piece worth focusing on. So look at the data, form a hypothesis about which code is at fault, then find another test case and see whether it fails in that same particular way. Confirm or discard and go around again. If you truly have no idea where to start, put print statements at reasonable places in the code. 2 places are always reasonable. The moment you first enter a function and the moment you first enter a loop. Inside the loop, print the loop variable every time around, and print every variable you create or modify in there. Here that means printing nums on entry, then printing n and the result at the top of each pass. You're not looking for anything clever yet. You're building a record of what the program actually did, so you can compare it against what you thought it would do. When you have no better idea, the bisection method is a reliable fallback. Put a print statement about halfway into the code and check every variable at that point. If everything looks right there, the bug is somewhere after that line. If something is already wrong, the bug is before it. Either way, you have thrown away half the program. Now put a print statement at the quarter mark and ask the same question. If the values match what you expect, the problem lives in the second quarter. If they do not, it lives in the first quarter. Each print halves what is left, so a long program surrenders its bug in very few steps. Here is the buggy function. It is called isPal. It takes in a list X, and it is supposed to return true when the elements read the same forwards and backwards, and false otherwise. First test case, the string ABCBA cast to a list. That really is a palindrome, so it should print true, and it does. The test passes. Second test case, the list holding just A then B. That is not a palindrome, so it should print false. It prints true. Now I have a failing case I can work with. The 13-letter run from A to M fails too, but I do not want that one. Always reach for the simplest failing input you can find, because every print statement you add will be easier to read. So AB it is. Step 1, print halfway through. There are only a handful of lines here, so there is really just one sensible midpoint. 2 lines do some work, then comes the if. Put the print right before the if, and have it print temp and then X. Now predict before you run. Temp is meant to hold the reverse of AB, so the first thing printed should be BA, and the second should be the original. Still AB. Run it. The first list comes back AB, not BA. The prediction failed, and it failed early. Everything from the if statement onward is now irrelevant, because the values feeding it are already wrong. The bug is in those first 2 lines. Step 2. Print at the quarter mark. Which of the first 2 lines is at fault? There is exactly one place left to put a print, right before the reverse. So now print in both places. Before the reverse, show temp and X, and after the reverse, show them again. Predict first. Before the reverse, the 2 should be identical because all that has happened is an assignment. After the reverse, temp should read BA while X still reads AB. Run it. Before the reverse, identical, exactly as predicted. After the reverse, temp is unchanged. The reversal never happened. The bug is that line, temp.reverse. So what is wrong with that line? Reverse is a function, and the line never calls it. Writing temp.reverse just names the method and throws it away. Python evaluates it, gets a method object, and moves on. Add the parentheses to actually call it. Predict again before the reverse, unchanged, because nothing was touched on the assignment line. After the reverse, temp should be BA and X should still be AB. Run it. Before the reverse, fine. After the reverse, temp is BA. The reversal finally happened. But look at X. X is now BA as well. The function still returns true. One fix down, and the answer is still wrong. There is the clue. We change temp and X change with it. That happens because the assignment temp is set to X did not copy anything. On a mutable object like a list, that line creates an alias. Two names bound to one and the same list. Reverse is through either name and both names see the change. So make a real copy instead. Take a full slice of X that builds a brand new list with the same elements, and temp is now independent. Run it. Before the reverse, temp and X are identical. After the reverse, temp reads BA and X still reads AB, exactly as predicted. The comparison is now false, so the function reports that AB is not a palindrome. Correct. Notice why one fix was not enough. There were two independent bugs, and each one on its own forces the answer true. Without the parentheses, temp never changes, so temp is always equal to X. With the alias, whatever happens to temp happens to X too, so the two stay equal no matter what. Either bug alone makes the function answer true for every input, which is exactly why the first test case looked like it passed. It never proved anything. Last step, rerun the case that already worked. The palindrome ABCBA still comes back true. That is a regression check, and it is the difference between fixing a bug and trading one bug for another. Two things to practice on. There is a list comprehension to write on your own and a Wordle game in today's zip file with bugs deliberately planted in it. Fix the Wordle game and you can play it, or hand it to a friend to play. Work it the way we just did. Pick the simplest input that fails, predict what each variable should hold, print at the midpoint, and let the disagreement between prediction and the reality tell you which halve to search next. The bug you find is disposable. The method is not. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.